Well, good morning again. Done a little bit more cleaning on the chassis. However, I wanted to go ahead and start labeling and getting rid of this Candohm resistor. The wires, we will be replacing those. I'm hoping that with the Candohm removed and this smaller capacitors that will go in place, and also these smaller resistors that'll go in there from the dog bones, that I'll gain a little bit more real estate in here. Now I think I can probably put a terminal strip here. I don't want to get too much into this vent area because this is here for a reason. I think that probably has to do with the transformer and heat from the Candohm, but Candohm is a heat sink against the back of this cabinet, so that's something. Hang on a sec, let me turn this down just a tad. Just turned it off. All right, but I think I should be able to get more real estate when I remove this. Also, these two caps, they'll be a lot smaller. So as far as the filter caps, I do not think I'm going to restuff those. I may remove them to clean them, but put them back just for historical purposes, and then hopefully can mount a terminal block or strip under here that I can put the filter caps in that area. That's the initial plan at this point in time, but we will proceed, and I've got to calculate and order the resistors for the Candohm to go back in. So that's where we're at right now. So let me just get back to it and plug away at it. Well, I've went and spent $18 on Dremel tools, bits. I'd lost one of my chucks and misplaced it. I didn't lose it. They go somewhere. I'm not sure where everything goes, but someday they'll find it. They'll find it. But I went ahead and used a high-speed bit on my Dremel tool, and I took the Candohm out. And now I've seen articles where people go in with a knife. Now this one's open already, but go in with a knife and cut these and then just use the terminals. Well, that's all good and dandy, but this is the center of feeding all the voltages to your radio. So I would have to see that, because why these wires open up sometimes, but there's paper in here, a certain type of paper, and they get hot and it burns through and usually shorts out or something. And so I think there's potential in rebuilding this, but I'm not going that route. So anyway, what I also did is I went ahead and removed the filter cap so that I can have more real estate, and I can clean them a little bit better. I don't think I'm going to try to rebuild these. I just don't. Let me flip this over and we'll take that tuning condenser off. I've got a pretty detailed schematic wiring diagram of this radio, so I'm not really worried. I went ahead and cut the wires just below the condenser, and this is it's riveted on in the front, but let's see. There's a bracket here with a grommet, which we'll have to replace, and there's grounding straps here, and I'm hoping that we will be able to lift this bad boy right up and off of here. I'm not quite sure. This bracket here is riveted down, so it stays. But I'm hoping that this is gonna. Okay, I see. Now we've got to lift. Should have lifted these grounding lugs up to start with, and then this comes right off, and then these rubber grommets. This one bracket back here, let me see if I can show you. This bracket right here has a rubber grommet in it, holds the back and pushes it into this with two rubber grommets. So we'll have to replace the rubber grommets, but this stays on it. So it can get bent, but I don't think it's going to be an issue. Let me document the bag and put this in, and this will give me more real estate to clean this chassis with. Okay, we're going to take a look at calculating the wattages for the Candohm resistor. The Candohm is made up of R21, 22, 23, 24, 25, and 26, and you can see on the photo on the screen. Now, R25 and 26 are below or the negative side of the chassis ground, so they will have a negative voltage across those, and we'll calculate those a little bit differently, and I'll show you how we're going to do that. But looking at how other folks calculated this, I had to sit down and I end up using, even though it had two voltages on the E91 schematic in riders, the E81, which does not have the Colorama, the only difference is it doesn't have the Colorama. To me, it had better documentation, and so I traced each one of those leads between the resistors, between R21 and R22 and etc., to their appropriate tube connections, and determined their voltage, the voltage that they were supposed to be. Now, based upon that, I determined the voltage drop between each resistor, and based upon that, I could determine the wattage. So it's just the way I ended up doing it. So I've seen several different ways out there, but that's it. Now, my wattages will be different wattages for each resistor. Now, some people will determine the largest and then just do a shotgun and just put them all that resistance or that wattage value, and that's fine. I mean, there's nothing wrong with that. It's just not the way I approached it. So let's I've got a hand drawing of my schematic and some of my calculations, and I'll show you how I came about. Okay, I hope you can see this. This is a crude drawing, not to scale, but it's how I came up with my calculations. Looking at the resistors, R21, 22, 23, 24, 25, 26, at the very top of them you'll see test point number 1. Now, coming from the drawing, that line at test point should be at 300 volts according to the schematic, and then that line runs on out to the plates of the 6L6 and the 6F5. All right. Then the next resistor down is R21. Well, that's a 1K resistor. Well, that line between R21, R22, it goes to the grid of the 6L6, and also the plate of the 6K7. I think that's the first IF. Well, the voltage to supply that was 250 volts. Well, if you do Ohm's law with just the voltage divider, the current would not equal that voltage drop. And the reason for that is that there is current coming or going to those plates or from those plates, and in addition to what's in the voltage divider resistor. So it's a little bit different. So what I did, I took the voltage drop between the test point 1 and at the junction of R21 and R22, and I determined the voltage drop was 50. And then I did the next one, and then the next one, and the next one, till I got down to the chassis ground. And then I did another way. I went around backwards, looking at the voltage drop across the negative side. By using this methodology, I determined that the voltage drop across the 1K resistor was 50 volts. The voltage drop across the 11K resistor was 150 volts, and then across the 15K was 98.5 volts, and then across the 210 resistor was 1.5 volts. Then we'll look at the negative side on another sheet there. But using this methodology, I calculated the wattages or the power each resistor used based upon the voltage that was being dropped across it. Let's look at the calculation for R21 for the 1K ohm resistor. If you look in the upper left hand corner there, you'll see that the voltage drop was 50 volts. So the power, you determine it by taking the voltage squared divided by the resistance. In this case, the voltage drop was 50. We square that and divide that by 1,000 ohms. So squared 50 is 2,500 divided by 1,000. That's 2.5 watts. And so I used a factor of approximately 3. You want to use between 2 and 3. So I used 3, and it showed to be 2.5. And so it ended up 7.5. I could have got by with the 7.5, but I ended up using a 10 watt. Looking at R22, that's the 11K resistor. The voltage drop we determined was 150 volts. Well, we took that 150 volts, squared it, and divided it, and I divided it by 10,000 because I'm going to use a 10,000 ohm resistor. So that was 22,500 divided by 10,000, and we come up with 2.25 watts. And I multiplied that by 2, and so I determined to use a 5 watt on that one. Now that sounds like that I wasn't as conservative on one as the other, but the other one was right on the 5. This is a little bit under the 5, so as 2. So but anywhere between 2 and 5. Now looking at R23, that's in the lower left hand corner, that's the 15,000 ohm resistor. The voltage drop there was 98.5 volts. So we squared that, and we got 9,702 or so, and divided that by 15,000. So we came up with 0.64 watts. We multiplied that times 3, and so I determined just to use a 2 watt resistor. Then the R24, it's 210 ohm resistor. The voltage drop was 1.5 volts. We squared that, we end up 2.25, divide that by 210, and the wattage was 0.011 watts. So I decided just to use a 1 watt resistor. So we got different size wattage resistors instead of just using, you know, the biggest or whatever. So all right, let's look at the negative side and see how I done that. Okay, let's look at R25 and R26. Those are the ones that come from the center tap of the transformer to the chassis ground. So this provides the back bias or set bias of this radio, and it's set at negative 16 volts. So we know that the voltage drop across R26 and R25 is minus 16 volts. The total resistance of those two resistors is 140 ohms. So we'll use Ohm's law in a different form. We'll use current is equal to the voltage divided by the resistance. In this case, the current is equal to the minus 16 divided by 140, and so, or we come up with about 114.114 amps, or 114 milliamps. So we'll determine the wattage of R25. First, we got to find what the exact voltage drop is across 25. So we'll look at it, and so we'll multiply. The voltage drop is equal to the current times the resistance, so 114 milliamps times 30 ohms, and that gives us a voltage drop of roughly 3.5 volts. So now we'll use that formula that we used on the upper side, where the power is equal to the voltage squared times the resistance. That's 12.5 volts divided by 30, and that equals to 0.41. So we multiply it times 3, and so we'll end up using a 2-watt resistor with that one. Then for R26, we do the same thing. We multiply 114 milliamps times 110 ohms, and we end up with 12.5. Of course, we could have just subtracted the 3.5 from the 16 and come up with the 12.5, but you can see that it works both ways. The powers, we squared the 12.5, that's 156. We divide that by 110 ohms, and that ends up to 1.4 watts. So multiplied that times 3. So I'm going to use a 5-watt resistor. So I've already got the resistors ordered, and when they get here, we'll determine the length of them and build a Candohm equivalent or replacement that'll mount right back in those holes again. So that is going to do it for now, and we'll wind this video up. I've got a lot of wires to replace, a lot of components to replace, and and some more cleanup to do. But I thought hopefully we got through this dry calculation of how to determine that the Candohm wattages. I'll let you look at the chassis as it's cleaned up a little bit more. Plan on doing a little bit more shining and a little bit more cleaning on the IF cans and the transformers, and then we'll start working on the underside and start getting the rat's nest out of it, of that wire. That wire is crumbly. I thought the wire in the Super Ed R7 was bad, but this is really, really, really bad. So it's every bit of it's going to have to be replaced. But we're going to wrap this video up for now, and we'll wait on the resistors and some more parts to come in, and then we'll on the next video we'll start really getting into, and in the meantime I'll start doing some wires and maybe some recapping. I've got some of the caps to go in it. So from Larry from the hills of Tennessee, thanks for watching.